Everything about black holes explained in 10 minutes. We're going over the birth of black holes, the formation, how these things literally make no sense in physics but make sense at the same time, and other things like us dying from it one day. Each part we talk about is going to blow your mind or make you question your place in the universe.
Is one of the biggest black holes ever discovered. British scientists at Durham University have found an ultra-massive black hole.
Imagine a cosmic vacuum cleaner so powerful, not even light can escape. But where are they from? Picture the biggest, baddest star in the galaxy, way more massive than our sun. When it can't handle its own gravity, boom, it collapses into a black hole. It's like a stellar meltdown, where instead of throwing a tantrum, the star becomes this invisible, all-consuming monster. As you ponder the immense power of such cosmic power, you might wonder, what if you took a trip into a black hole? Sounds like a wild ride, right? As you get closer, time would stretch out and slow down. It's like watching a movie in super slow-mo, but you're the star. As we approach the event horizon, the black hole's point of no return, let's shift our focus to stars, picturing them as giant, glowing gas balls, mostly hydrogen, just hanging out in space. They're so big that their own gravity causes them to collapse. Inside, it's like a wild party where hydrogen atoms are smashing into each other, creating helium and releasing a ton of energy. This energy is like the bouncer at the club, keeping everything balanced and the star stable. But stars are overachievers. The big ones, much larger than our sun, start cooking up heavier elements in their core. It's like a cosmic kitchen where hydrogen and helium are just the appetizers. These stars keep fusing elements together until they hit iron. But here's the twist. Iron is the party pooper. When a star starts making iron, it stops getting energy from the fusion. This is like the moment the music stops at a party, and everything gets awkward. So, what happens when the star's energy runs out? It collapses under its own weight, faster than you can say black hole. This collapse is so intense that the star implodes, moving at 1/4 of the speed of light. In this cosmic meltdown, heavier elements are created, and the star goes out with a bang, a supernova. This could either lead to a neutron star, or, if the star is really feeling dramatic, a black hole. And just like that, in a cosmic blink of an eye, a black hole is born. It's like the universe saying, surprise, you thought it was just a star, but it's a super dense, light-gobbling black hole. This is where the heavier elements in the universe come from, the aftermath of a star's grand exit. As you explore the leftovers of a cosmic explosion, you might be curious to say, let's take a peek at a black hole. What you're actually seeing is the event horizon, sort of like the black hole's do not cross tape. Anything that dares to cross it needs to be faster than light to escape. Spoiler alert, that's impossible. So what we end up seeing is this big, mysterious black sphere, like the universe's own magic 8-ball that forgot to answer your questions. Now, if the event horizon is the black hole's keep out sign, what's inside? That's the singularity. It's the heart of the black hole, where all its mass squishes into an incredibly tiny space. Imagine taking an elephant, shrinking it down to the size of a pinhead, but it still weighs as much as an elephant. What's really wild about black holes is that the singularity could be infinitely dense, which means all its mass crammed into a space so small, it basically doesn't exist. We're not sure what's going on there. It's like the universe threw us a puzzle without all the pieces. Some say it's like dividing by 0, it just doesn't compute in our brains. Ever wondered how time works near a black hole? It's like the universe's own slow-motion button. As you get closer to a black hole's event horizon, time starts to crawl. Imagine you're walking towards a black hole, and to your friends watching from a safe distance. You look like you're moving in ultra slow motion. It's like you're starring in your own epic movie scene, but the universe is holding the remote. Here's where it gets even wilder. Right at the event horizon, you'd appear to freeze in time like a statue. To your friends, you're just hanging there, slowly turning red, and then, poof, you vanish. Meanwhile, from your viewpoint, everything in the universe is fast-forwarding. It's like you've got a front-row seat to a cosmic time-lapse, watching stars and galaxies whiz by. From your perspective, falling into a black hole would be a journey into the future. You'd see the universe's history play out at lightning speed. It's as if you're binge-watching the entire story of the cosmos, while everyone else is stuck on pause. Imagine seeing stars being born and dying in the blink of an eye, galaxies spinning like cosmic merry-go-rounds. It's a time traveler's ultimate fantasy, minus the DeLorean. So black holes don't just mess with space, they twist time too. They're like nature's way of showing us that time is not just a simple ticking clock. It's a flexible, stretchy thing that gets all wobbly around these cosmic giants. Remember, if you ever get near a black hole, wave goodbye to your friends. You'll be on a one-way trip to the future, unless you get spaghettified first. Let's say you take a wild plunge into a black hole. What's the grand finale? Well, first off, you'd experience what scientists call spaghettification. It sounds like a pasta party, but it's less tasty. Imagine being stretched and pulled like a piece of spaghetti. Your cells would stretch out, and you'd become a stream of atoms, thinner than a noodle. It's like the universe's weirdest makeover. But wait, there's more. As soon as you cross the event horizon, you might meet a fiery fate, like hitting a cosmic firewall. It's like the universe's way of saying, game over. You'd be gone in an instant, zapped out of existence. It's a bit like touching an invisible electric fence in space, but way more intense. Think of black holes as the universe's collection of wild beasts, each unique in size and strength. There are the stellar mass black holes, sort of like cosmic small fry. They pack a punch, with a few times the mass of the sun, but are only as wide as an asteroid. Imagine a tiny marble with the weight of a mountain. That's your stellar mass black hole. Then there are the big bosses of the black hole world, the supermassive black holes. These giants are found lounging at the center of galaxies, including our own Milky Way. They've been feasting on cosmic meals for billions of years. Think of them like the universe's most voracious eaters, never saying no to seconds. The largest supermassive black hole we know of is S50014+81. This behemoth is 40 billion times the mass of our sun. To put that into perspective, it's like comparing a grain of sand to a mountain. Its diameter is a whopping 236.7 billion kilometers. That's 47 times the distance from the sun to Pluto. It's like the universe decided to go big or go home. It turns out, even these cosmic giants have an expiration date. Thanks to something called Hawking radiation, black holes slowly evaporate away. Imagine a really slow leak in a tire. It might take ages, but eventually it'll flatten. That's kind of what happens to black holes, but on a much, much grander scale. Here's a bit of a brain teaser. Empty space isn't actually empty. It's more like a bustling city for virtual particles that pop in and out of existence. Near a black hole, these particles get quite the workout. One particle falls in and the other escapes, kind of like a cosmic dance where one partner gets left behind. This escapee particle takes some energy from the black hole, which means the black hole slowly loses its might. As black holes lose energy, they shrink. It's like they're on a really long diet where they gradually lose mass. When a black hole gets down to the mass of a large asteroid, it's as if it's just chilling at room temperature. Then, as it gets even smaller, say the size of a mountain, it starts heating up. In its final moments, it goes out with a bang, erupting with the energy of billions of nuclear bombs. So what's the final act for a black hole? It's not with a whisper, but with a bang. But don't hold your breath waiting for this cosmic fireworks show. Even the smallest black holes will take longer than you can imagine evaporating. By the time the last black hole says its goodbyes, the universe will have moved on, with stars and galaxies long gone. It's like the universe's longest goodbye, with black holes being the last guests to leave the cosmic party.